Hi everybody, this is Mr. Folly, and welcome to Podcast 2.2 Periodic Table, where we're going to talk about all of our trends: electronegativity, ionic radius, reactivity, valence electrons, charge of ions, and a little noble gas stuff, which we already talked about. Let's hop to it. Explain the main way atoms differ, and you just explained every trend. So this is the answer for why, we did this in class, this happens all the time. Size. Bigger is less attractive. High school romances don't last through college. So if this is America, if this is America and your little honey goes to school here and you go to school here, because you're so far away, the attraction falls apart and you split up like that. See? Nuclear attraction. More protons means more attractions, unless the person is really attractive. Hubba, 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 hubba. And you'll follow them anywhere. We call that desperate and a stalker. Keith. Electronegativity. Ability to attract electrons in a bond. Thou shalt, you should, covet thy neighbor's electrons. The trend. Fluorine is the Mac Daddy. Remember how we had our little pictures of the periodic tables? Whoop. Fluorine's right here. Fluorine is the best at attracting electrons in a bond. Francium is over here. Francium is a big loser, and we'll learn why that's true. So if we're trying to attract electrons, I'm not trying to lose electrons. Francium is down here, francium, and francium is a big loser, so it's the worst at it. Why? Fluorine is small and is attractive because it has so many protons for its row. Remember, protons equal attractiveness. It's like money, right? So it will be able to attract bonded electrons easily. So the richer you are, the easier it is for you to get a date on a Friday night. Sad, but probably true. So again, why is fluorine the best? Fluorine is small because as you go this way, it's smaller, and is attractive because it has so many protons for its row. So it will be able to attract bonded electrons easily. Attracting bonded electrons is what electronegativity is. Notice how I said size and more protons. Atomic size. As you go down, remember it gets bigger. Dot with a circle. Dot, circle, circle. Little circle, little circle, little circle, bigger circle. So as you go down, it gets bigger. And to the left, it gets bigger because there are, so that means the biggest element is francium. Biggest. Because it's less attractive, because it has fewer protons. So it's like it's poorer. So if two people are equally attractive, so two potential dates right here are about the same size. This one's got less money than that one. Well, you might as well go with a rich one. Everything else being equal, go to the one that's more attractive. Okay? This one is more attractive. Why? Because it has more protons. And what do we think of protons as? Money. And money makes people more attractive. This is terrible. Ionic radius. Remember, ions are anything with a charge. This is the size of an ion. Cations get smaller. Why? They lose electrons and energy levels. So if you've got your little nucleus here and you've got a ring of 2, and you've got a ring of 8, and you've got a ring of 1, if you lose one electron, look at how, so we'll say out to here, let's say this is 100 units distance. If I get rid of this, bam, look, I'm way shorter. I'm only like 40 units big now. Okay, except for I misspelled units. Anions get bigger. Why? So if I put this back on here, if I have this one electron, and I put another electron here, what they do is they repel each other. They repel each other and spread out. That's why anions, remember those are negative ions, they repel each other and spread out. Good. Valence electrons are outermost electrons. We talked about this. So make sure you keep writing this stuff down. So the valence electrons are S and P. Okay? They're also periodic. So the number of valence electrons you have are 1, 2, 3, 4, 5, 6, 7, 8. So that means how many valence electrons does K have? 1. How many valence electrons does indium have? 3. How many valence electrons does selenium have? 6. How many valence electrons does argon have? 8. The one exception to that is helium, just has 2. Valence electrons help determine charge. I want to be full. 8 is great. So remember, this guy has 8. If I have 7, right? I'll put this in the bottom. If I have 7 electrons, I have to gain an electron to get to 8. So that means this is -1 because 7 plus 1 equals 8. Okay. Down here I have 6. Well, I want to have 8. 6 plus 2 is 8. So 2 electrons would be -2. Here I have 5. Well, if I want to have 8, I gain 3 electrons. Electrons are negative. That's it. Now I'm going to hop over here. So if I have 1 valence electron, remember how I showed before? If I lose one, I'll be +1 and I'll be full. So if I have 19 and I lose 1, I'll have 18 and that would be full. Here I'm going to lose 2. It means I'm going to be +2. Over here I'm going to lose 3. It means I'll be +3. Now this guy's right in the middle, so he doesn't do anything. So 0. Metals and nonmetals react differently. Metals lose electrons. They become positive. Yay, metals are happy. Nonmetals gain electrons. They become negative. The best metal reactor is francium. It's a big, unattractive loser, like the country of France. It's big because many energy levels. It's unattractive because few protons for its row. Best nonmetal reactor is fluorine. It's small, attractive stealer. Small because few energy levels. Attractive because most protons for its row. Ding. So periodic table and most reactives, this is the most for nonmetals. But then I have to change for metals. Metals are different, right? So red is metal. And then this is nonmetal. Whoops. Nonmetal. Noble gases never react, though. Why? They are full. Remember, when you're full, you don't commit crimes. Electronegativity, ionic radius, and atomic radius all have definitions you must memorize. I need to know the definitions? Yes. Size and attraction explain it all. FR and F are the most reactive of their types. F is the Mac Daddy. FR is a big loser like France. Toodles.